Somewhere in space, there's a galaxy that should not exist. It is as big as our Milky Way. It has stars, it has structure, it has everything a galaxy needs. Except one thing. The one thing scientists said every galaxy must have to survive. And when NASA's Hubble Space Telescope looked at it, astronomers could not believe what they were not seeing. To understand why this is such a big deal, you need to understand dark matter. You cannot see dark matter. You cannot touch it. You cannot photograph it. But scientists are almost certain it is there. It makes up roughly 85% of all the mass in the universe. Think about that. Everything you have ever seen. Every star. Every planet. Every galaxy and every photo ever taken by Hubble or James Webb. All of that visible stuff is just a small slice of what is actually out there. The rest is dark matter. Invisible. Silent. Everywhere. And here is why it matters so much to galaxies specifically. Galaxies spin. Stars orbit around the center at incredible speeds. And when scientists calculated how fast galaxies are spinning, they found a problem. There is not enough visible mass to hold them together. Not even close. If galaxies only had the mass we can see, in stars, gas, and dust, they should be flying apart, ripping themselves to pieces from their own spin. But they are not. Something invisible is holding them together. Extra gravity. Extra mass that we cannot detect with any telescope. Scientists call this dark matter. And for decades, it was considered a rule. Not a suggestion. A rule. Every galaxy needs dark matter to exist. It is the scaffolding, the glue, the invisible skeleton every galaxy is built on. At least, that is what everyone believed. Until they found NGC 1052 DF2. To be fair, dark matter itself is already one of the strangest ideas in modern science. Nobody has ever captured a particle of it in a lab. Nobody has ever photographed it directly. We only know it exists because of what it does, not because of what it is. It bends light as it passes by, an effect called gravitational lensing. It holds galaxy clusters together that would otherwise fly apart. It leaves fingerprints all over the structure of the universe, even though it never once shows its face. So when scientists say every galaxy needs dark matter, they are not guessing. They are describing a pattern that has held up galaxy after galaxy for as long as we have been able to measure it. That is exactly why DF2 was such a shock. It was not a small crack in the pattern. It was a pattern completely failing in a galaxy sitting right there for anyone with a good enough telescope to see. Stick around, because what this galaxy reveals next breaks a rule scientists thought was unbreakable, and it's about to force them to rethink everything we know about how galaxies form. NGC 1052 DF2. That is its official name. Most people just call it DF2. It sits about 65 million light-years away, in the constellation Cetus. The first thing astronomers noticed was strange. DF2 is huge, roughly the size of our entire Milky Way galaxy, but it is almost see-through. Astronomers describe it as a ghostly galaxy because you can look straight through it and see other galaxies sitting behind it in the image. Why is it so faint? Because it barely has any stars. DF2 has around 200 times fewer stars than the Milky Way, spread across the same enormous area. That makes it what astronomers call an ultra-diffuse galaxy, a galaxy so spread out and so faint that it almost hides in plain sight. Ultra-diffuse galaxies were already unusual. Astronomers had only recently discovered this whole class of them. But DF2 was not just faint. DF2 was about to become one of the strangest objects ever recorded. Because when the team studying it, led by astronomer Peter Van Dokkum at Yale University, tried to measure how much mass DF2 actually had, the numbers made no sense. Here's the part that's almost funny. DF2 was not discovered by some enormous, headline-grabbing observatory. It was spotted using a telescope called the Dragonfly Telephoto Array, a custom-built instrument in New Mexico, essentially made from a cluster of high-end camera lenses arranged specifically to hunt for objects too faint and too spread out for normal telescopes to notice. Van Dokkum's team built Dragonfly for exactly this purpose, finding galaxies that hide in plain sight because they are too diffuse to stand out. And it worked better than anyone expected. A 2015 survey using this instrument revealed that these ultra-diffuse galaxies were far more common across the universe than anyone had assumed. But even among a class of galaxies built specifically to be strange and faint, DF2 stood out as the oddball of the oddballs. Here is how you weigh a galaxy without a scale. You cannot put a galaxy on a giant cosmic weighing machine, so astronomers use motion instead. Inside DF2, there are clusters of stars called globular clusters. These clusters orbit the galaxy, just like planets orbit a star, and the speed at which they orbit tells you something important. It tells you how much gravity is pulling on them, which tells you how much mass the galaxy actually has. If a galaxy has a lot of hidden dark matter, its globular clusters should be whipping around fast, pulled by all that extra invisible gravity. So the team pointed the Keck Observatory in Hawaii at DF2 and measured the velocity of 10 of its globular clusters. What they found stopped them cold. The clusters were moving slowly, way too slowly, slow enough that the only mass pulling on them appeared to be the visible stars themselves. No hidden extra gravity, no invisible scaffolding, nothing. Based on the math, DF2 had at least 400 times less dark matter than a galaxy its size should have, possibly none at all. Let that sink in for a second. This was not a small discrepancy. This was not a rounding error. This was a galaxy that, according to everything astronomers understood, should not be able to hold itself together. And yet there it was, sitting quietly, 65 million light-years away, completely stable. Van Dokkum has said he spent hours just staring at the Hubble image after it came in, trying to process what he was looking at. That reaction says a lot. This was not a scientist casually noting an interesting data point. This was someone staring at a result that seemed to break physics as he understood it. Because remember what dark matter actually does inside a galaxy. It is not just extra weight sitting around for no reason. It is a reason galaxies do not fly apart when they spin. Picture a merry-go-round spinning too fast. If you are not holding on tight enough, you get flung off. Galaxies spin fast enough that their visible matter alone should behave the same way. Stars and gas should go flying off into deep space. Dark matter is the hand holding everything on. Extra invisible gravity, keeping the whole structure intact. So a galaxy with next to no dark matter should, by every existing model, be in the process of tearing itself apart. DF2 was not tearing itself apart. It looked calm, stable, ordinary, aside from the one glaring fact that its invisible glue appeared to be missing. But here's where it gets even weirder. Because this discovery didn't just surprise scientists, it triggered a fight inside the astronomy community that lasted years. When the results came out in 2018, published in the journal Nature, the reaction was not universal excitement. It was skepticism. A lot of it. Some astronomers pushed back hard. They argued the distance measurement to DF2 might be wrong. And distance matters enormously here. Because if DF2 were actually closer to us than calculated, its mass estimate would change completely, and the missing dark matter might just be a measurement error. Other scientists proposed different explanations. Maybe DF2 was not really a stable, isolated galaxy at all. Maybe it was a fragment, ripped away from a larger galaxy during some ancient collision, its dark matter stripped away in the process. The debate got intense enough that entire research papers were published specifically to challenge or defend the original findings. So Van Dokkum's team went back to work. They needed better data, more precise measurements, undeniable proof. They returned to Keck Observatory, this time using a more advanced instrument called the Keck Cosmic Web Imager, which could observe the entire galaxy at once with extremely high precision. The new results confirmed the original finding. The globular clusters were still moving at a speed consistent with almost no dark matter present. This new instrument had a specific advantage. Instead of measuring clusters one at a time, it could observe the galaxy's diffuse starlight and all of its globular clusters together in a single pass with very high spectral precision. That meant far less room for error and far less room for skeptics to argue the result was some kind of instrumental fluke. The lead researcher on this follow-up study, astronomer Sheni Danilai, explained that the instrument's wide field of view combined with its precision was what made the measurement possible at all, since nothing else available could do both at once. The skeptics did not go away entirely. Science rarely works that cleanly, but the weight of evidence kept shifting in one direction. And then something happened that made the case even stronger. They found a second galaxy. In the same group of galaxies, sitting near DF2, astronomers identified another ultra-diffuse galaxy. They named it NGC 1052 DF4, or DF4 for short. DF4 looked almost identical to DF2. Similar size, similar brightness, similar structure, same rough distance from Earth, and about 65 million light-years. And when they measured its globular clusters, they got the same shocking result. DF4 was also missing most, if not all, of its dark matter. This changed everything about how seriously the scientific community had to take the discovery. One weird galaxy could be an anomaly, a mistake, a one-off. Two weird galaxies in the same region of space with the same bizarre property was a pattern. Since then, researchers studying the wider NGC 1052 field have kept finding more faint, diffuse galaxies lined up in that same region, hinting there may be a whole family of these dark matter-deficient objects clustered together, not just two isolated flukes. If that holds up, it means finding galaxies like DF2 is not a 1 in a billion coincidence. It means there's a real physical process out there capable of stripping galaxies of their dark matter, or in some rare cases, building galaxies that barely have any to begin with. There's something almost poetic about how DF4 was confirmed. Van Dockum has pointed out that finding a second galaxy like this was just as thrilling as a first discovery, because it meant the odds of finding even more of them were higher than anyone had assumed going in. Think about the statistics here for a second. If DF2 had been a total fluke, a 1 in a million measurement error, the odds of stumbling onto a second nearly identical galaxy in the very same small patch of sky would be astronomically small. That is exactly why DF4 mattered so much. It turned a bizarre outlier into the first data point of an actual scientific pattern. Now here's the part that actually matters to you and me, because this isn't just a fun space fact. This discovery is being used as a weapon in one of the biggest arguments in modern physics. There are two competing ideas about dark matter. The first idea says dark matter is real. It is an actual, physical substance made of particles we have not detected yet, just waiting to be found by the right experiment. The second idea says maybe dark matter does not exist at all. Maybe our theory of gravity itself is slightly wrong, and once we fix the math, galaxies behave correctly without needing any invisible mass. This idea has a name: modified gravity. For years, critics of standard dark matter theory pointed to modified gravity as a simpler explanation. No invisible particles required. Just tweak the equations. But DF2 became a problem for that idea too. Under most modified gravity models, a galaxy like DF2, without real dark matter, should not be able to hold together and rotate the way it does. Its stars should behave differently than what astronomers actually observed. In other words, DF2's existence was used by dark matter researchers as evidence against modified gravity, not for it. And here is the twist that makes this discovery genuinely beautiful, according to the very scientists who found it. If dark matter did not exist as a real substance, if it was just an illusion from bad gravity math, then every single galaxy should show the exact same effects, all the time, everywhere, with no exceptions. But DF2 is an exception. A galaxy that plays by completely different rules than every other galaxy we have ever measured. And an exception like that only makes sense if dark matter is real, and if there is some process that can strip it away, or leave it out entirely in rare cases. Ironically, a galaxy missing dark matter became some of the strongest evidence that dark matter is actually real. There is a phrase astronomers use when they talk about dark matter's role in the universe. They call it the scaffolding that all galaxies are built on, the invisible structure holding the visible universe in shape. DF2 and DF4 do not fit inside that scaffolding. They exist almost entirely outside it, held together, it seems, by nothing more than their own ordinary matter. For modified gravity theories, that is a serious problem, because those theories predict this situation should never happen. Every galaxy, under those models, should show the exact same gravitational quirks all the time, with zero exceptions. For standard dark matter theory, DF2 is actually a strange kind of gift. It shows that dark matter behaves like separate, physical stuff, something that can, under the right violent conditions, be stripped away from a galaxy and left behind, rather than being baked permanently into the fabric of gravity itself. In science, sometimes the best proof that something is real is discovering the rare place where it is missing. So what actually happened to DF2 and DF4? Scientists have a few leading theories. One idea, violent birth. Some researchers think these galaxies formed from powerful gas outflows, blasted out of a larger galaxy during intense star formation billions of years ago. Gas gets ejected, and it eventually collapses into a small, diffuse galaxy made almost entirely of stars, with little to no dark matter ever gathering around it. Another idea, cosmic stripping. In this scenario, DF2 and DF4 originally had normal amounts of dark matter, but repeated close encounters with a nearby massive elliptical galaxy in the same group gradually tore that dark matter away over billions of years, leaving behind a stripped, ghostly remnant. Both theories are still being tested. Neither one is fully proven. What is clear is that DF2 and DF4 are not following the standard playbook for how galaxies are built. Something unusual happened to them, and researchers are still working out exactly what. There is a third possibility some researchers have floated to, that DF2 and DF4 are the leftover cores of much larger galaxies that collided with something bigger, with almost all their dark matter, which tend to sit in a wide halo around a galaxy rather than packed in tight at the center, torn away during the impact while the dense inner stars stayed roughly intact. Under this theory, dark matter and ordinary matter respond very differently to a violent collision. Dark matter, spread out in a loose halo, gets stripped away easily. The stars, packed more tightly together, hold on and survive as a smaller, dark matter poor remnant. If that is what happened here, it would mean DF2 and DF4 are not new types of galaxies at all. They are the scars left behind by ancient cosmic violence, still visible 65 million light-years away, billions of years later. And this is where the story gets bigger than just two galaxies. Because if this can happen twice by accident, it changes what astronomers have to search for next. Since DF2 and DF4 were confirmed, astronomers have gone looking for siblings. They have scanned other ultra-diffuse galaxies across the sky, checking each one for the same telltale sign. Globular clusters moving too slowly for the galaxy to be hiding much dark matter. Most ultra-diffuse galaxies checked so far still show normal amounts of dark matter. That actually matters too, because it shows DF2 and DF4 are not just a natural feature of every faint galaxy. They are something rarer. Something specific happened to them. But researchers keep finding hints of more candidates scattered through the same general region of space around NGC 1052, suggesting there may be an entire trail of these unusual galaxies still waiting to be confirmed. With newer instruments coming online, and with astronomers now knowing exactly what signature to look for, more discoveries like this may not be far away. Every new one found either strengthens the case that dark matter is a real, physical substance that can be stripped away, or forces scientists back to the drawing board completely. This is also where newer technology is starting to change the game. Wide-field space telescopes now coming online are built to survey huge patches of sky at once, instead of zooming in on one target at a time. That means they can scan for faint, diffuse galaxies across enormous volumes of space far faster than older instruments ever could. Combine that with better ground-based spectroscopy, capable of measuring the motion of very faint globular clusters with more precision than what was available back in 2018, and the pace of discovery here could accelerate fast. What once took years of dedicated observing time on a single galaxy might soon be possible for dozens of candidate galaxies at once. If DF2 and DF4 really are just the first known members of a larger, hidden family, that family may not stay hidden for much longer. Step back for a second and think about what this actually means. For decades, dark matter was treated almost like a fixed law of nature. Every galaxy has it. No exceptions. Full stop. Then astronomers pointed a telescope at one quiet, faint galaxy 65 million light-years away, and that entire assumption cracked open. It turns out the universe is not as uniform as we thought. Galaxies do not all follow the same recipe. Some of them break the rules completely, and figuring out how and why they do it is teaching scientists more about the other 85% of the universe than almost any other discovery in the last decade. We still cannot see dark matter directly. We still do not know exactly what it is made of, but thanks to a ghostly, see-through galaxy that should not be able to hold itself together, we know more about what dark matter has to be than we did before. Sometimes the biggest discoveries do not come from finding something new. They come from finding something missing. And that is worth remembering the next time you look up at the night sky. Every galaxy you can see with the naked eye, every one you have ever seen in a photo from Hubble or James Webb, is only telling you part of the story. The visible universe, the stars, the gas, the glowing spirals and swirling nebulae, is just the surface. A thin layer of light sitting on top of something far larger and far stranger that we still cannot see directly. Most of the time, that invisible framework holds everything together exactly the way physics predicts. But every so often, out in the vast dark spaces between galaxies, the universe hands us an exception, a galaxy that plays by different rules, a ghost hiding in plain sight, 65 million light-years from home. And every time that happens, it is a reminder that we have not figured everything out yet, not even close. If a galaxy without dark matter blew your mind, wait until you hear what happens when two black holes collide, and one of them goes flying out of its own galaxy at 1,000 kilometers per second. I made a full video on that. Watch it next. And if you want more of these deep space mysteries, hit subscribe, because this channel is just getting started.